Okay, all right, my Math 130s. Unfortunately, my last video is on my computer that is currently not working. So I'm hoping that that'll be up within the next few days, but we'll see. I might have to just do the entire video again, which sucks. So today what we're gonna get into is the homework alternate for chapter 6, which covers roots and radicals. The first thing I'm gonna do is give you guys a definition for roots and radicals. Essentially, you can use them interchangeably. So for a root, you're going to have something of the form. Okay, that didn't work. Okay, so you're going to have your root. This part here, the n, is going to be called your index. And you're going to have A. A is going to be your radicand. Okay, so essentially, A can either be a number, or we're going to find out that they can be factors and things as well. So we're going to practice a bit with this. So hopefully you're already familiar with some of the roots, like square roots. For those ones, you do not see an n value here. Okay, what that means is that n is equal to 2. There's also cube roots. And those are roots with 3 as the index. And your radicand. Okay, one more little detail. This bar here is actually called your root or radical sign. Okay, and now we can continue with the roots. You can also have fourth roots. Fifth roots, and so on and so forth. Let me go ahead and save that picture. So now essentially what this index does, it tells us how many of the same factor we have to have underneath the radical sign before we can remove anything from the radicand. So to further go with that, I'm going to get into question 1 here. What number is equal to square root 16? So you might already know this. Let me clear this out. But essentially, if we have square root 16, we can break 16 into 4 times 4. Okay. Essentially, using our exponents, that's 4 squared. So essentially, the square root is going to cancel out the square here, and then you're going to be left with 4. Now, would you need to show all this work for that kind of problem? No. As long as you're comfortable knowing what the square root of 16 is, you could just write 4. Okay. Let me save that, and then let me continue for now. I'm actually going to add one in here. Um, okay, so what number is equal to square root 27? So let me go ahead and take a pause here from recording and I'll come right back. Hi all, sorry, there's one change I want to make here. I actually want to have the cube root of 27. Okay, let me pause. All right, so basically following our rules here, we have the cube root of 27. 27 breaks into 3 times 3 times 3. And that's going to be the same as 3 cubed in your radicand. So the cube root undoes the cube, and you're left with 3. Okay, let me save that. And then I'll go ahead and clear this out. Let me move down a little here. Okay, so sorry, trying to get all my oh, come on. My drawing bar won't move, and it's right in the way of my problem. Come on, let me move. Okay, hold on, let me pause the recording. Okay, that's not working either. All right, had to rearrange all kind of stuff. So question number 2, we have a kite flying in the air, has an 11-foot line attached to it. Its line is pulled taut and cast a 7-foot shadow. Find the height of the kite, and if necessary, round your answer to the nearest tenth. So you might want to have a calculator for this part. All right, so essentially, remember, we learned the Pythagorean theorem a long time ago. You have legs A and B, and you have hypotenuse C. Remember the Pythagorean theorem states leg squared plus leg squared equals hypotenuse squared. So in this case, we see that we have A and we have C. So we're going to be looking for B. Okay, so let's go ahead and plug in the values that we have. We have 7 squared plus B squared equals 11 squared. It's going to be 49 plus B squared. That'll be equal to 121. So then we're going to subtract 49 from both sides. We have B squared, oops, equals 72. Okay. And then essentially in this next step, we're going to learn how to isolate your B when you have an exponent here. So that's where your roots come in. we're going to take the square root of both sides. Okay, so we have square root b squared equals, and we're actually going to learn about this in a little bit. When you take a square root of both sides like this, you need a plus minus. Okay. And so the square root cancels out the square. You have b equals, in the Pythagorean theorem case, you're only going to use positive since it's a distance. Okay, and so you're going to use your square root button. So put 72 square rooted, and you get a 8.4852 and change. So careful here, last step, you need to round to the nearest tenth. This would be the 10th place. So you're going to look at the 8 to round. So that tells us that b should be equal to about 8.5. And that's feet. Okay. For the next bit, question number 3 is going to be somewhat similar to our warm-up, the way I set it up. So I'm actually going to backtrack and go to the warm-up for a second. I don't think I recorded that part, so I'm going to go ahead and just pause while that occurs. Hold on. All right, so in case, well, you did miss it because I didn't record it, haha. But anyway, so for our warm-up, we were looking at how to solve this particular problem, and we did it via factoring and zero product property. Review that and let me know if you have questions. We could also solve this another way, and that's using what's called the square root property. So essentially for that part, if you have an x squared here and you only have a power of x squared, so you don't want an x to be in here somewhere. We'll talk about that later. But essentially isolate the x squared and then take the square root of both sides, but you need to add a plus minus in front. So this is a good method for understanding why we have a plus minus. All right, let me clear that out and keep going. So question 3, find all real square roots of 64. What that's asking you, essentially, oh, come on, man. You probably see all kind of crapola happening here from your end. Okay, there we go. Jeez. Okay. Essentially, the real square roots would be x values. Like if you decide to use x as a variable for this. But essentially what this is saying is, what number squared gives me 64? Okay. Would you need to set it up this way? No, especially if you're already comfortable with the two numbers that will do this. But essentially, remember your square root property. And from here, you would have x equaling positive 8 or x equaling negative 8. Okay. A little bit of vocab. If you have a positive radical like this is called a principal or positive root. If you have a negative out in front of that root 64, you have the negative root. Okay, so just be mindful. We'll see this in practice a little bit later, but if you're simplifying these, so suppose you have a question, simplify square root 64, you would only get one answer, 8. Simplify negative square root 64. Well, square root 64 is 8, but there's a negative in front of that. Okay. But here we had a solving problem, hence why we got 2 answers. Okay. If you need to take a picture or something, if you want to, I'm going to go ahead and clear this out and move to number 4. Okay, for number 4, you're asked to simplify square root 81 over 100. There are a few rules here, so let's look at rules of radicals. First rule is product rule. If you have the square root of A times the square root of B, that's the same as the square root of A times B. And this works for any root, so as long as they're the same index. Okay. The second rule is quotient rule. And for this one, you have the root of A times the root of B, quotient. You have the root of A divide root B, and that gives you the same thing as root A over B. Again, the index can be any number as long as it is the same. So for number 4, we have root 81 over 100, which looks like our right side over here. So you can actually break that up into root 81 divided by root 100. And root 81 is 9, and root 100 is 10. Okay, let me save that. And I'm going to pause recording just to check in. Okay, y'all. This is gonna be number 5 that we do next. I'll just do it right here. So we're asked to evaluate the square root of negative 36 and negative square root 64. Well, let's just start with this one down here since we've already covered it. Remember, square root 64 is 8, and there's still a negative in front. Now, be very careful with this one, though. We're going to learn by the end of the chapter how to handle this, but for now, this wouldn't be a real number. And essentially, the reason for that, you have to worry about this with even roots. The problem stems from the negative being underneath the radical sign. Essentially, kind of think, what two numbers could I multiply that would give me a negative number that are exactly the same? So like I could take 6 times 6, but that's 36, right? I have negative 6 times negative 6, but that's still 36. The only option for getting a negative 36 would be a negative 6 and a positive 6, and that is not the same number. Okay, so not a real number here. To kind of skip a little bit ahead in terms of what that would come out to. So but later in chapter 6, we cover imaginary numbers, which sounds funny because it's like, what? They're not really there then. But they are very much there. I like to give this diagram. Essentially, here's the real number system. And that includes whole numbers, natural numbers, like any number that you've been working with so far. So rationals, irrationals, whole numbers, integers, etc. Now, all of those systems are included in the real number system, and then the real number system is included in what's called the complex number system. So every real number is a complex number, but not every complex number is real. Okay, so to give you a little insight into that, the form for imaginary numbers, standard form, you would have a plus bi. A is the real component of the number, and b is the imaginary component. Okay, let me erase some things. Okay, so let me select this first, move it up. Okay. So quick example, if I have the number 6, 6 can be written as 6 plus 0i. So this would be the real number, and this would be the complex number. Okay. All right, so now with all that said, let's bring it back to what's happening here. If we have square root of negative 36, this is going to come out to 6i, where I is equal to the square root of negative 1. So we'll look back like more into this, how we would get this in detail as we go forward. But for now, I'm just going to leave it at that. Let me go ahead and clear everything. Okay, that time it worked. Okay, number 6 is next. Evaluate the following. You have to be careful here. Essentially, negative 2 to the 4th power is going to be negative 2 multiplied 4 times. Okay. Essentially, So this part would turn into positive 4, and this part would turn into positive 4. So it's actually the same thing as square root of 16, which is 4. An alternate method you have the square root of negative 2 to the 4th. That's square root negative 2 squared, negative 2 squared. Out from here. Oh, sorry, that was not the way I wanted to do it. Hold on one second. Oh, okay. I know how I wanted to do it, but I don't think I've explained this part yet, and I think I'm going to want to wait on that. If you can follow, go ahead, but you can make this into a 1/2 power, the radical. If you're not sure why yet, just wait on it. We'll talk about it soon. But essentially, this would be negative 2 to the 4 halves, which is negative 2, the quantity squared, which is still 4. So just use this method for now. Woo. All right, let me save that. Next thing, I'll actually leave part B for you guys to try. That way I can get through more problems. Save and clear. Okay, let's go over number 8 first, and then number 7. Number 8, we already did, so that's why I want to go over it right now. Remember, this is cube root of 3 cubed, which is going to give you 3. Keeping in that spirit, let me go ahead and do number 9 before I do 7. So remember, we had that quotient rule for radicals. We can change this to cube root 8 divided by cube root 125. The cube root of 8, what 3 numbers multiply to 8? That's going to be 2. What 3 numbers multiply to 125? 5. Okay. All right, questions 7 and 10 are going to be very similar. We're going to use a process here, and I think I'm going to bring an activity for us to try next time that's been pretty successful in my previous classes, where we simplify radicals with different indices. Okay, so let me go ahead and clear. So we're going to do number 7 now. We have square root 64 w to the 10th, and we are trying to simplify it, which means you don't want to leave any perfect squares underneath your radical sign. Okay, so let's draw a radical here. Remember, 64, that's 8 times 8, or 8 squared. And then w to the 10th, that's 10 w's. 5, 6, 7, 8, 9, 10. Let me extend this radical sign. That's really important. Okay, I lost a radical and some w's. I need it here too. Okay, so how many did I lose? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So one way that you could say this, that's actually w to the 5th squared. Okay, now formally, you would split the radicals. And then you would get 8 for the first bit, and you would get w to the 5th for the second bit. Okay, before we continue on to part 10, I do want to bring the mention of the radicals being fractional exponents now. So I'm going to go ahead and move this up. Radicals are fractional exponents. Remember, we had the root before. It was the nth root of a. That's actually the same as saying I have a to the 1 over n power. Okay. So example, if I have square root a, that's a to the 1/2. If I have cube root a, that's a to the 1/3, and so on and so forth. So an alternate method that you could have used for number 7, let's see. I think I'm gonna just erase. I'll erase this. Could have said, okay, I have 64 w to the 10th. That's going to be the same as 64 w to the 10th to the 1/2 power. If you've forgotten your exponential rules, review those, please. You're going to have 64 to the 1/2 power, and you're going to have w to the 10th to the 1/2 power. 64 to the 1/2, so that's going to be 8 squared to the 1/2 power. And then over here, you're going to have w to the 10th to the 1/2 power. So remember, you would multiply exponents. 2 times 1/2 is 1. So you get 8. And then 10 times 1/2 is 5. So you wind up getting the same thing. All right, let me do a quick check-in here before I start going over number 10. And I think that's going to be the last problem that I introduce for the night that's new. Let me presume. All right, so we covered number 7. Now we're going to cover number 10. Clear all my drawings. So for number 10, you see it down here. You have a cube root 8v to the 15th. We'll do this problem two ways. One is going to be the radical way. Radical way. The other one's going to be the exponent way. So over here we have the cube root. We know that 8 is going to be 2 cubed. And v to the 15th, I hate to do this, but I'm actually going to write out all the v's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah, crap. All right, you know what? I'm just gonna erase that 9. It's like faster to just write it again. Okay. So we have cube root. And I'll just write it like this too. 2 times 2 times 2. And then we have 15 v's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so now essentially one way that you can do this without having to write the exponents in here, this tells you, the index tells you how many factors you're looking for before you can pull out one of them. So what I mean by that, we have 2 cubed here, right? So if I take the cube root of that, then what do I get out? I get out 1, 2. Okay, so inside the radical, every 3 2's comes out as 1, 2 outside the radical. All right, now you also have your group over here, so you need to find groups of 3. 1, 2, 3, 4, 5. So technically, that's V. Oh, sorry, one thing. That's going to be 1V, another V out, another V out, 5 V's out. The reason I left it off here is because if you're trying to think about pairing that off as a third power, it would actually be V to the 5th to the 3rd. And then the third power cancels out with the root. So your final answer for this would be 2V to the 5th. Now the exponent way over here, that would be starting with your 8V to the 15th, and you're taking that to the 1/3 power now. So you're gonna have 8 to the 1/3 power times V to the 15th to the 1/3 power. 8 is 2 cubed, and that's taken to the 1/3 power. And then you have a I'm going to leave this one, V to the 15th to the 1/3 power. Okay, so remember here, if it helps, you can kind of think this is 2 to the 3rd, and then that 3rd power will be multiplied by 1/3. So that would just give me 2 to the first. And then over here, we have v to the 15th. That 15 is going to be multiplied by 1/3. So that's going to give me v to the 5th. So again, I get the same thing 2 different ways. All right, let me save that and let me move down a little for a second, see kind of where we're at here. Okay, I guess I can't do that. Okay, yeah, so this is actually a pretty good place to stop for right now. So let me go ahead and stop the recording. Okay, come back, recording box. Oh my goodness, come on.